Today we're going to learn how to find the area and perimeter of a parallelogram. Here's what you need. Your textbook, turn to page 54, open up to problem 3.1, a graph notebook, ruler, a pencil or pen, and of course you need your iPad or you wouldn't be seeing this video. Hit pause and make sure you have all that ready. Once you have all these materials, hit play and proceed to the next slide. So the question we want to ask ourselves today is, how can we use what we know about the area of rectangles and triangles to solve for the area of a parallelogram? The three questions I want you to answer right now, write down the formulas for each of these three. Number one, what is the formula for the area of a rectangle? Number two, what is the formula for the area of a triangle? And number three, what is the formula for the perimeter of a shape? I want you to pause right there and take a couple minutes to answer these questions. If after 2 minutes you can't seem to recall, then you can press play and move on to the next slide. So hopefully when coming up for these formulas, the first one you had was area of a rectangle was area equals length times width. So if we have our rectangle, we've got our length and we've got our width. And we just go length times width. For a triangle, like this, which is a normal right triangle, we've got our base and our height. And what we've realized is that a triangle is just half of a rectangle, right? So that becomes area equals length times width divided by 2. Except with triangles, we replace L with height and W with base. So the formula becomes area equals base times height divided by 2. For perimeter, it's just adding all the sides. So the rectangle would be length plus width, add length plus width, or 2L plus 2W. For a triangle, it would just be the three sides. So it would be base plus height, and then let's say the third side is C plus C. So now let's look at a parallelogram. Let's just draw this one out. Apologize for my crooked lines. What would be the base and height of this parallelogram? We know the base is the bottom, right? So we know that this will always be the base. But then where's the height? So if we think about what we did with triangles, right? Because essentially when you look here, you've got a triangle here, right? Or you've got a triangle here. So if you think about climbing to the top of that triangle or to the top of that triangle, right? And dropping a rock straight down, what becomes your height? This becomes your height. So if we draw that again, right? Let's make it a little bigger. Right? We've got that triangle that we create right here, or right here. Our height becomes this, right? So we start to look, but even though that can be a little confusing, right? So you've got your base and your height, but how does that correlate to the length and width? Well, let's look a little bit more. Let's look at your textbook. So make sure you're on page 54, right? So again, here we've got our base right here. And we've got our height right here. similar to just a rectangle, where its base and height. But where would be the base and height on this third shape? Again, you've got base, but how would you find the height? Climb to the top, drop a rock, climb to the top, drop a rock. So there's a couple ways you could find it, but this is your height. So again, you've got your base and you've got your height. So before we move on to solving the problems in the book, you've got 6 parallelograms in front of you. The question I have for you is the area the same for all of these, or are they different? Take a minute to think about that. After about a minute or so, you can press play and then proceed to the next slide. So what did you come up with? We know the area of this one is 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6, 7, 7. So 5 by 7, so 7 times 5 is 35 square units, right? So let's look at this one. Is it the same? Is it different? Again, let's think about, remember, we know our base is 1, 2, 3, 4, 5. But what is our height? And how can we figure that out? Well, we can make a triangle out of this, right? We can make a triangle out of this. So if we climb to the top, drop that rock, we find that our height is 1, 2, 3, 4, 5, 6, 7. 7. So our area is 35 squared units. Let's try this one. What's our base for this one? 1, 2, 3, 4, 5. So we're seeing something similar. But this one, again, how could we draw the triangle? Well, let's climb to the top of the slope, drop it straight down, and see what forms. So if we do that, our height is 1, 2, 3, 4, 5, 6, 7. So 7, again, 35. What about this one? These look completely different. We've got the base of 1, 2, 3, 4, 5, 6, 7 by 1, 2, 3, 4, 5. And we get 35 squared units. Again here, 1, 2, 3, 4, 5, 6, 7. But we've got to find our height. So we can climb to the top, drop a rock, climb to the top, drop a rock. So there's a couple different ways you can do it, and you get 1, 2, 3, 4, 5. So 35, if we do the same here, we get 35 squared units. So another way I want you to think about parallelograms is you look at that first one where it's a rectangle and the base is 5 and the height is 7. You can see that the base never changes and the height never changes, even though the angle changes. So essentially, a parallelogram is nothing more than a rectangle that's kind of blowing in the wind, right? When you think about when you stand up and you got a really, really heavy wind in a hurricane, imagine it blowing you to the side a little bit, right? Although you're leaning to the side, you're still the same height. And your width, or your base, between your feet is still the same, right? That doesn't change. It just blows. So when you think about being able to straighten that parallelogram up and make it look like a rectangle, which is essentially what you're doing when you're drawing that triangle on both sides, you're essentially changing that into a straight up and down rectangle. Then solving the area becomes much more clear. So you've learned that the area of a parallelogram is area equals base times height, or length times width, which is very similar to, or is that of a rectangle. And we practiced this a little bit, but you can go on Khan Academy yourself and do this. But check this out. So why does it work that way? You see this parallelogram here that we've drawn. If you put your finger right on this green dot, you can slide it over and see how that becomes a rectangle, right? So if we go down to this, practice problem 1, we could say the area of this parallelogram is base times height, which is 80 square units. But that might be kind of confusing. But if we take this and slide it over, you realize we've now made it into a rectangle. And then you type in 80, check it. And you are right. So, practice problem 2. Even when they look like this, you can again just slide it. So this is a good thing to try out, and I'll leave the link on the website as well for any questions that you, or on the lesson as well for any questions that you might have. Now it's your turn. I want you to solve problem 3.1, parts A, B, C, and D. I don't want you to work on this for more than 20 minutes, and you may struggle, and remember what we talk about, that's okay. As long as the struggle is positive, but when it turns to frustration, that's when you need to stop. Send me any questions you may have. I then want you to complete the ACE problems number 1 through number 7. That's 1, 2, 3, 4, 5, 6, and 7 on page 64. You'll submit these via a Google Classroom assignment. Again, I'm always available for questions if you need help.